Hello everyone, welcome to Grade Up. My name is Ayush Goel and we are studying compiler design in these videos, right? Up till this point, we saw in our recent video that what are the phases of compiler, okay? We discussed 6 phases of compiler and we take a common example to describe the flow of those 6 phases. Now, as I said, that now I'll discuss those phases in detail, right? So our first phase of compiler is lexical analyzer, right? So let us start about lexical analysis, right? Let us start. See, everything now you know. What are the basics of lexical analyzer? See, the first phase of compiler is lexical analyzer, which is also called scanner. As I said to you, that lexical analyzer will scan the whole program. So it's also known as scanner, right? Lexical analyzer will divide the given program into meaningful strings known as tokens, right? You know this thing, that this. See here, lexical analyzer, you give input string and what will you get? Token stream, right? So I have written the same thing here. Lexical analyzer will divide the given program into meaningful strings called as tokens, right? Now what are the types of tokens? See, identifier, A, B, C, D, A1, B2, C2, sim, operators, plus, minus, equal, keywords, right? Special symbols, hash, dollar and constant, 60, 70, 80, right? So these are the different types of tokens, right? Now see, the next phase of lexical analyzer is parser, or you can say semantic analyzer. Oh, sorry, syntax analyzer. Syntax analyzer or parser, both are the same thing, different names, okay? So I can say lexical analyzer and parser works simultaneously. Why is it simultaneously? See, when a parser says give next token, a parser will demand a token. When a parser demands a token, then only lexical analyzer scans your source program and produces a token. I am repeating once more. Lexical analyzer and parser work simultaneously. How? When a parser wants a token, then only lexical analyzer scans your program and produces token, right? So, and as symbol table is generated, symbol table is basically connected to all the phases as we discussed, right? So now main thing is lexical analyzer and parser work simultaneously. Got it? Any doubt up till here? Good. Now, what are the functions of lexical analyzer? See, first thing, dividing the given program into tokens. That is a majority function, right? It produces tokens by dividing the program. Next, skipping comment lines. It will skip the comment lines. Suppose if I write like this, void main, right? This is my comment. Right? Comment is something written like welcome. And suppose close. Now, when lexical analyzer scans this program, it removes this comment. It skips this comment. Comment is for users. There is no advantage or no significance of comment for the computer. So that's why it will skip these comments. Now, there are two things for, inserting the comments in your C program, if you remember. First method is this. And now write a comment. Next method is this. Put a star, any comment and then again star. So there are two methods to declare or insert a comment, right? Please remember this. While doing the questions, these methods are used. So skip these comments. Right? Now, skipping blank spaces and white space characters. Suppose, see here. My name is Ayush Goel. Now these are the blank spaces, enter, white spaces and all. So these are all skipped by the lexical analyzer. Lexical analyzer don't count these blank spaces or white spaces, right? These things are skipped by lexical analyzer. Got it? Now, giving error messages by providing row number and column number. See, if you have compiled your C program, if there is any error has occurred, it will return the row number. There is an occur in row this and column number this. So this is done by lexical analyzer. Got it? So these are the functions of your lexical analyzer. Any doubt? Good. Now if you remember, I have told you in applications of finite automata. You have studied TOC now. Applications of finite automata. The first application was, it is used in lexical analysis. If you remember this or not remember, you can view that video again, right? Application of finite automata, the first application was, it is used in lexical analysis. Now, how does it use? See, I have taken a very small DFA. See, the final states are 2, 3, 4, 5, 6, 2, 3, 4, 5, 7 and 8. These are the final states. Now, what does this final state denote? See here, this is a starting state. This is your starting state. Now see, less than equal to, you go like this, less than equal to. So if you return, now you done less than equal to. So these are the operators, you can say. These are the operations you are going to perform or some comparison you are doing, right? So if you go like this is the lexical analysis. Lexical analysis means scanning. So you are scanning your program. Suppose while scanning you got something like this. So you will go less than, then equal. So what will you return? Return less than equal to. Got it? Same like here. If you got something like this, it is not equal to. Less than, greater than, then will be not equal to. Similarly, if you got any other, return less than or simply other than thing. Suppose you got less than A. So you simply return less than. It is nothing other than that. Similarly, equal to, greater than equal to, not greater than, and so on. Got it? So this is the finite automata application. I have told you that I'll explain at the time of compiler. So I'm explained here. Right? Now guys, what are the questions that are being asked on lexical analysis? Only two types of questions are asked. First type of question is counting number of tokens. This program will be given to your lexical analysis. How many number of tokens will it generate? And the second question can be the theory question, right? So first see these type of question, counting number of tokens, right? How to count? See, count line by line. See here. Int main, this and this. How many tokens are there? See, 1, 2, 3 and 4. So how many tokens? 4 tokens are there in this line. Now this is a single token. Now this, how many tokens? This is a comment or not? So this will be skipped by your lexical analyzer. This will not be counted. Now int a equals to 10, comma b equals to 20 and semicolon. Now count tokens yourself. Count please. 1, 2, 3, 4, 5, 6, 7, 8 and 9. How many tokens? 9 tokens in this line, right? Count line by line. There will be no confusion at all. Then if a less than b, count again. 1, 2, 3, 4, 5 and 6. So here 6. Can you try now? Can you try yourself now? Here, don't count like this. RET. No, return. Return is a keyword. So that will be a token. So 1, 2, 3, 4 and 5. 5 here. Then else is a keyword. 1. Here again. 1, 2, 3, 4, 5. 5 here. And finally 1 here. Now do the total. See, 4 plus 1, 5. 9 plus 5, 14 and 6, 20, 25, 26 and 5, 31 and 1, 32 tokens. So 32 is the answer. That's how you need to find the tokens. That's why I said that time. Please remember, comments are skipped. Got it? Any problem in this thing? Now, can you try the same for second example? Count number of tokens. Again, I have given some code, right? Go line by line. 1, 2, 3 and 4. So 4 tokens here. This is a single token, 1. Now this is important. See here. Printf grade up and close. Now count the tokens. See, printf is a single token. It is a keyword. This is a single token, 2. Now the things which are kept in a in commas, the things which are enclosed by commas will be counted as one only. Will be counted as one, a single token only. Okay? It will not be splitted, GRAD or something like that. It will not be split. If something is written in inverted commas, that will be clubbed as a single token. Please remember this. So 3 and this one will 4 and 5. So in this there are 5 tokens. I am repeating once more. The things which are enclosed in inverted commas separately will be counted as a single token. Got it? Now here 1, 2, 3, 4, 5. Here 5 tokens, right? Now see this, x plus plus, x plus plus. So x is one token. Now plus, you can take plus as a single operator, but no. Plus plus is an increment operator. You know, plus plus is an increment operator. So that's why it is counted as a single token. 1, 2 and 3. Here 3. Clear? Now int star y. Int star y. Now here 1 star y. Star y is specifically something or not? No. Star y denotes pointer. So take it separately. 2, 3, 4. Right? It not becomes any keyword or any operator. That's why separately. 4. Can you try for same? Y equals to and %x. Again, and %x doesn't mean anything. Right? So 1, 2, 3, 4 and 5. Right? 1, 2, 3 and 4 and 5. And finally here it is 1. Now do the total. 4 plus 1, 5, 10, 15, 18, 22, 22 and 5, 27 and 1, 28 tokens. Cleared? Now now you understand how to count the tokens, right? Any doubt in this? Good. Now see a previous year question. Now we are completed with lexical analysis. Now do some previous year questions. As I said, only 2 types of question will be asked. Either theory, either counting number of tokens. See, in a compiler, keywords of a language are recognized. That means, what does this statement means? Keywords of a language are recognized means you are recognizing keyword. You are scanning the input and recognizing keyword at which phase? The lexical analyzer phase. C option is correct, right? So this is an example of a theory question. Got it? Next, see, GATE 2000. Find the number of tokens. See, printf is 1 token. This is 1 token. This bracket is another token. Second, now this thing, inverted commas, as I said, will be clubbed as a single. Third, this comma is 4th. This I is 5th. This comma is again 6th. This and % is 7. This I is 8. This bracket is 9. And this semicolon is 10. So overall, how many tokens? 10 tokens are there. Cleared? Any problem? Right? So that's all about our lexical analysis. Very easy topic, very easy, right? Now what you do? You pick up any book, Ullman, or you can see for previous year also, questions are asked on counting number of tokens, okay? Now go and attempt those questions. Practice those questions, count number of tokens yourself, okay? This is the most probable question from lexical analysis, right? So now this is over. Now in our next video, we'll start from parsing, syntax analyzer. Parsing is the majority topic, as I said, okay? Maximum time we'll study parsing only, right? So from our next video, we'll start parsing, okay? Now stay updated. Thank you so much.